The first type we're going to dive into in detail is going to be lists, because those are going to be the most common that you're going to run across. The idea of a list is it does everything the collection does. I can add stuff into it, I can remove stuff out of it, I can iterate through it and stuff like that. But as we said before, the most important aspect of a list is it keeps the order in which things were added. Which one was added first, which one was added second, and I can move things around in the list. So the features of a list, because I'm keeping track of it, is I can add things at an index, I can get things at an index, I can remove or replace things at an index as well. That means a list left to itself, just adding and removing items, you always know the order in which things were added. But since I can manipulate where things are on the list, I can actually sort lists. I can rearrange them based off of however I want to. The rules of what's in a list is up to me and how I'm going to store it. But part of those rules is going to be defined. How it's stored is going to be defined by how the list is created. So there's a couple different types of lists that are predetermined inside of Java, that come with Java. An array list, a linked list, a vector, and a stack. Now, it's not super important that you understand exactly perfectly the algorithms that go behind this. But if you were truly a computer science student, part of your education would be, what is a linked list and how do you create a linked list? And you'd be asked to actually write one of these on your own without any supporting libraries that do this. So I want to give you a high-level picture of how these things work to give you a foundation of what's going behind the scenes, and then a little bit of choice of, well, which one would I choose? Honestly, it doesn't matter. 99.9% of the time, people will choose array list out of here. So if you are really like up to your eyeballs in a lot of new information, pick array list and live with that. It'll be perfectly fine. Nobody will fault you for it, anytime soon. So a couple of things about these is one of the features of these things are whether or not they're thread safe. Now, thread safety, we'll learn about threads a little bit more in the next class in 351, but threads are a way of doing things in parallel, having two things go on at once. So you think of it this way. Two of you could share a textbook, and each of you could read the textbook, and as long as you're taking turns reading the textbook, there's no contention. But if both of you want to read the textbook at the same time, one of you could be on page 5, the other one want to be on page 10, there's going to be a contention issue. Well, which page do you flip to right now? Vectors and stacks have protection against that built in. Array lists and linked lists do not. It's up to you to make them thread safe. Now, past that, at a high level, array lists are built to store things as an array. And so they basically function as an array. They can access things very quickly, but adding new items can be expensive. If I used up all the elements in the first array, then I've got to literally create a new array, copy everything over, and then make it bigger. As opposed to a linked list, accessing individual items is a little bit shorter. We'll see why in a minute. But adding new items in is instantaneously. I can make it as big as I want to, and you can never really tell the difference inside of there because of the way it's stored. Vectors and stacks are very specific purposes. They're very infrequently used by you as a coder. The idea of a vector is it's really the original linked list, or array list, inside of there. It was built very early on in Java and essentially has been thrown away because you'll use an array list or a linked list instead. But it has a way of internally controlling the size and dealing with things at a basic level. The stack is a very operating system type tool. It has this idea of peeking and popping. A stack, think of it as a stack of papers. I don't typically have a stack of papers and pull off the bottom one. I typically deal with the top one. So as I peep things onto the top of the stack, then they're the first to come off of the stack. So that behaves slightly differently that way. We'll see that in a little bit more detail as we go. So individually now, an array list, as we said, is stored as an array. So you see the fluffy cloud of the array list, around here. Inside of that is an array. And it stores exactly as an array, 0, 1, 2, 3, 4, 5, 6, 7. It starts off with a default size. I don't know what that default size is because it depends on your Java implementation. It changes. It's behind the scenes. But maybe it starts as being 8 here. And so I store 0 through 7. And when I go to 9, typically what it does is it makes one twice as big. So it'd make one that's 16 big. And then if you fill up 16, it'd make another one that's 32 big. And when it makes the new one, it copies everything over. So think of it this way. I have a piece of paper that's 3 by 5 card. When I fill up my 3 by 5 card, I jump up into an 8.5 by 11 piece of paper. When I fill up that one, which I start by copying everything from my 3 and 5 by 5 card to the first one, when I fill up that one, then I go up to a legal pad, that whatever length that is. Copy everything over. When I fill that one up, I go to a poster board. When I copy everything over, when I fill up that one, it keeps getting bigger that way. So the quick thing about that is I know everything's on that card. I can say go to line 7, boom, I got line 7. I go say line 40, boom, I got line 40. I just hop down there. I know where they are. But it can be very slow to add new items. So these are not frequently used when I have fast growing or dynamically growing lists, but they are typically used everywhere else. These are the most common ones used. Now, a linked list works a little differently. It uses internal storage where I have these series of nodes. Think of it as like a bunch of Post-it notes. So I put a Post-it note on the wall, and then when I add a second one, I put it next to it and put arrows in between it. I had a third one, I added one next to it and put arrows between it. I had a fourth one, you get the picture. So it grows quickly. It literally grows until I run out of wall space, and in Java there is a limit, the amount of data that's on memory that's on your computer. At that point, it'll stop adding objects. So there is a limit to it, but up until that limit, it can keep growing infinitely. They can have thousands or millions of objects inside of the list. If I want to get to the 57th item, I've got to go to the first one and say 1, 2, 3, 4, 5, 6, 7. Follow the arrows till I get to 57. So it's very slow to get to a specific node compared to the array list where I can just jump to line whatever, but it's much quicker to be able to expand a lot of data. So if I have a lot of data, I'm not sure how much data I'm going to add, I want to maybe break off and reorder lists a lot, linked lists are really, really great. But otherwise, they're typically defer to the array list. And we'll give it less attention on the last two, but do want to mention them. The vector is basically the same implementation as the array list. It was original to Java. It really shouldn't be used anymore. The biggest thing is it's by default thread safe, which makes it slower because it has extra mechanisms over the top of it. So you can use it. You will look either like an old school Java programmer or more likely an inexperienced Java programmer if you do it. So I want you to be aware of it. If you see it inside of other people's example code, that's what it means. Probably use the array list instead. The stack, as I said, is very similar. It actually extends out the vector class. It does everything the vector class does. It's basically an array list, but it has the functionality push, pop, and peek. So push, as we said, puts a piece of paper at the top of the stack. Pop removes a piece of paper from the top of the stack. And then peek allows us to look at that piece of paper but not take it off the stack. That's the three features that really make up a stack. Now, the most important thing here is that you can identify these things. That's really what I want you to see out of this 10 minutes we're going to spend together. As I said, most likely in this class you will only use array list, and they only mention array list. But linked list is also viable. The more important thing to mention here is you should be using the list interface, as we'll see in code. And thus, it doesn't matter which one of these you use. Which of these you choose should be about a 5-second decision as you type the name one time in code, and then you'll never see it again. We'll see what that means in code, but I want you to think about this. This is just a choice. You want to understand it conceptually, but it really doesn't mean anything to how you use a list. So let's go on, keep looking at more of these, but we'll see some code very soon.